Hi, everyone. Welcome to another episode of ProjectPro Expert Talks. We are honored to have with us today Alex Liu, PhD. Alex started off his career with a MS and PhD in Statistical Computing from Stanford University. And since then, he's had a career spanning over 20 years, first as an entrepreneur and then as an assistant professor at leading universities, the University of California System and the University of Southern California in LA. And Alex has also been a consultant to leading startups, including Shopzilla. After that, Alex went on to become the chief data scientist and distinguished data scientist at IBM. And currently, he's the founder and CEO of RMDS Labs, which focuses on creating an ecosystem to provide data science training. Alex also happens to be the president of the Global Association of Research Models and Data Science based out of LA. Alex, thank you so much for taking time to do this.
Thank you, and good meeting you here.
One of the things our viewers are curious about is, when people typically apply for jobs, there's a job role of a data scientist and there's a job role of a big data engineer split up into two. But these two worlds seem to be coming together. And you've kind of worked on stuff on both areas of data science and also deploying that on big data pipelines. Can you help us understand how are these two roles different? How are they coming together? At what point does the handoff happen? That'll be helpful.
Thank you. I think this is actually very important and good question because ideally, and people will think, okay, if I work in somewhere, then I just want to do the modeling. Give me the perfect data, and I just apply a model, get results. My work is done.
Yeah.
But in real world, and especially when you work for business or any other places, it's different from school, and the data is not perfect, and often you need to work with dirty data, and also you have data from different sources. Like for business, you have data from HR, from transaction department, and also from outside. So there's a huge amount of work to be done in terms of getting data organized and clean and prepared. And so in the field, people often say that if you work on both, and most time, people need to get involved in both, then you will need to spend 80% of your time just for the data preparation. However, in big companies like they are still needing to have some kind of division of duty, right? So you will see rules for data engineer. So those are the people and mainly working on getting data together, merge them and clean them and prepare them for modeling. Mm-hmm. Then there will be data scientists whose main focus will be on modeling, give me data, so I will apply a decision-making model or a regression or deep learning, then to get some results. Then you need to focus on the modeling part because there's still a lot of work to do. And however, still, when you are in fine-tuning your model, sometimes you need to go back to data. Maybe it's a data problem. So these two are not completely separate. But however, for big companies, there will be different kind of focus. So I think for people who apply, then you can then want to think about your background, your strengths, and pick the one you really like and want to progress, because there will be two different kind of focuses. However, they kind of still intact with each other.
Okay. That's helpful. And I've seen a lot of people who start off in big data with the intention that eventually they'll become an ML engineer or a data scientist. What do you think of a career strategy like that? Do you see that happening a lot, or?
There are some, but right now the data science is has been utilized widely. So I kind of see people from all kind background to become a data scientist. However, if you can start with some knowledge about the big data, is still quite useful, and even it's not as useful in a few years ago. And because at that time, like big data technology is not that well developed. So if you have special skill in dealing with big data, you will have some advantage. However, now it's like everywhere you need to deal with big data. Big data is everywhere, and also the technology has been well developed that it's kind of become relatively easy to access. So I think still, and in order to be successful in this field, it's kind of like the capability to manage everything together, combine it together will become even more important.
Okay, understood. Okay. And in your career, you have worked and consulted for companies and startups across spectrum, from e-commerce to finance to services, all of that. So while working on data science problems across these industries, what stay the same and what changes? I mean, obviously the data changes, but otherwise, what kind of tools or frameworks stay the same? What changes? Would love to hear that.
I think like years ago, then there was quite a big separation, even the tools, right? Then like for statistical modeling, used like marketing or business people like SPSS, then people in finance and in healthcare will usually prefer to use SAS. But I think for now, the separation is not that clear, and not like everybody has adopted certain type of like common tools, and also certain type of like popular like a deep learning type of like strategy models. But however, there's still some like different kind of focus. For example, like in business, when you study customer, like you want to calculate the customer life value, then you probably will have to use survival analysis, those type of models, which will not be, you will not see utilized in finance or other field. So there will be some kind of focus, like in the financial area, and then you may see decision tree random forest used a lot for scoring risk or for like detecting frauds. So the in terms of the models, I think usually you will see some clear differences.
Okay, understood. Got it. And while you were working at these companies and you were recruiting uh, candidates to join your team, what were some of the maybe the top two or three filters you would use to hire the right people?
Yeah, I did a lot of interview in the past for IBM and other companies as still for our RMDS. And in terms of like interviewing data scientists, I actually and prefer to look at uh, the communication skill, because right now is that like many tools are widely available, so it's not difficult, even some like automation tools. So it's not difficult to get some data and then even put into a system automatically, you can get some results. However, how to communicate about what you have done and communicate the results, and especially to decision makers, then that's very, very important skill. And the second, I think I will look at the logic and the how organization, like in terms of how this person is capable to really organize they have done. Because like, like we, as I mentioned, for data scientists can be very complicated, from data to model to data engineering, feature engineering, and it's a very, very long process, and it's complicated. And but still, like your coworkers and your boss will need to know what you have done and why and what you produce is good. Then so it's very important to get everything organized. So that's I think what I usually will pay a lot more attention than other stuff.
Communication and the ability to just organize.
Yes, organize the things. Other because you sometimes encounter this data scientists that they will sit in the corner and then present you really good results. But if you ask them, and they have difficult to explain, and also like then you give them another work, and then after 2 weeks you ask him to come back to that work, and then he probably forget what he has done. Then will create a mess, even with some kind of smart engineers or data scientists.
Okay, that makes sense. Okay. And that leads me to my next question, which is you started RMDS Labs a couple of years back. Could you tell us what RMDS Labs is about and how did you get the idea to do that?
It's RMDS Lab coming from two the reasons. So one is that when I was with IBM and other company, I have been still actively involved in the community building for data scientists because we start kind of early for the community building. So we were able to create and have a very big community for data scientists, around like 40,000 people and the participants. So that's one reason we feel like we want to create an organization to serve this community. And the second is that from my experience working with different companies, I realized and a lot of data science work has been done and have like some like good results in looking, but however really did not solve the problem and did not help the users. And even like Gartner has also some kind of survey that they're reporting 70 or 80% of the data scientists actually failed. Failed means like they were not able to really provide the insights, help the users or solve the problems. And they can produce some nice graph and the nice tables, but didn't solve the problems. And around that, I did some research. Actually, I done that at we can propose a new approach called, and for this approach, and I feel like there's a need and a very important need and to get this developed and implement. So that's why I come out to start RMDS Lab. So our main purpose is to build a platform for data scientists, researchers, and we have a very good foundation already, so people can join and use our platform, then at least add some value to them and make them more likely to be successful for their projects.
Understood. And a lot of the learning on the RMDS platform happens with the community helping each other, is it? Is that how a lot of the learning happens?
Yes, and that's another important feature that we call the collaborative needs for data scientists. As I mentioned, right, and data science and the process can be very complicated, and as a human, it's quite easy to make mistake, and also, and everyone their the knowledge or expertise and experience is also quite limited. So really, in order to be able to successful, it's always better to have some college to have some peer insight that you can use, and will definitely improve the successful ratio. That's why we can really encourage people to collaborate so they can join our platform, then register there. We have a good system for them to know each other, interact, then get some quicker peer support, peer insights.
Okay. So I was just wondering, in your career as a data scientist, could you share some tips or tactics that you've used to get your work done faster or your projects done more efficiently?
Yes, thank you. This is also very important question because like in the real world, and everybody face challenges, like I mentioned, per Gartner, and the successful ratio is actually very low. But even so, in real situation, quite often that especially in business, and the leadership usually will give you a project, and you will not be giving, but not be giving a lot of time. They will say, I want this results this week, or sometimes even today. So in that way, like it's very important that you can quickly pull everything together and the data together. That's important. And so, we really need a very good data portal ready, so you can access huge amount of data and different kind of data. And the second is that I think I feel very important and useful is you have some examples, like project examples. So you need to do not need to reinvent everything. And the second, and even and better is that you have this example and expressed as workflow, right? So like and mostly it will be good is that a reusable workflow. So you have what like everything laid out. Then for us is that we have like a 4E framework. You have the model, equation selector, and the algorithm estimation part, and also evaluation, then execution.
Yeah.
So then when you have a task, you know, ask to do something, you can quickly pull this. Then you just need to modify and some little things, and then quickly get some results. And from there, you keep improving, then we'll get good results. Then I think that will make things a lot easier and also more efficient.
Okay, understood. Got it. And there is a framework that you invented called the RM40 framework. Could you just briefly walk us through where is it used and how does it help?
Yeah, and this one actually came out first of all when I was doing some structural equation modeling, and in there, and everything is quite very well structured. Like you need to do the model specification, then after that, then you need to estimate, right, the model, get the coefficients. Then after that, you need to evaluate. If it's good, then you go to explain the model or execute the model. And if not, then you go back to modify data or go back to equation and modify the estimation. So overall, simply, you actually, we kind of many people agree that this 4 E's covered the main element of a data modeling process. And the luckily is that after I come out this and the 4 E's, people really like it because especially for training or other like education places, it's very easy for people to remember, right? Oh, it's a 4E. So if I get the 4E, I got the main components of data science process covered, and which is why like 4Es and get quickly adopted in many places, and for training and also for organizing the workflow. And so now is that we also I see some project come in, and we will also do some. Is that they can use this 4E as an interface, and in the back, then there will be a lot of AI machine support. So for people to easily manage a research process, and also kind of manage all the workflow, even store a lot of workflow for reutilized. So in that way, people will be able to be more efficient. That's like what we describe. I understand like some of your vision is similar, is that you want to provide a lot of project example.
Yeah.
So like if you go further, then you can use 4E, then like to organize everything as a workflow, and it will be easy for people to remember and to pick up, right? And also like because the 4E can also be easily recognized, organized by the machine. So with the machine support, then we'll make everything, mainly the research support, a lot easy for everyone. Because right now is that the challenge for data scientists is that many of them actually are very creative, innovative. They have good ideas, but you even get to your one idea implement. There's a lot of work, right, with the data, and also with organizing all this workflow and the machine support to get all this tedious stuff and organized and handled. Then the data scientists will have more time for innovation, for creativity. And I think all this together would be wonderful for everyone.
Okay. That's helpful. I think, adding workflows to our projects is a feedback that we get quite often. I think we'll explore the 4D framework to see how it can help us do that. Yeah, great. Thank you very much, Alex. This is really the questions I had. Really appreciate taking time to do this.
Thank you. And I also see during this process, we kind of figure out there may be also some opportunity for us to really collaborate to support your vision of supplying project examples to your users and our 4Es and also the community collaborative system, and maybe able to provide some assistance. I look forward to this as well.
Absolutely. We would love to do that as well.